Yes, today we discuss about that dipole moment. So majorly I have to one trick to find out easily find out the dipole moment of any molecules. So first I have to write down the dipole moment formula mu equal to Q into D. So mu is a we have to denote it dipole moment always a mu. So here Q equal to charge, then D equal to distance. So always dipole moment is a vector. So vector factor so that here dipole moment always you have to show the in crossed arrow. This is a crossed arrow. So here crossed arrow. So this arrow always starts from less electronegative element to more electronegative element. More electronegative element. So this is actually majorly you can easily find out that dipole moment. For example, I will give one molecule here H and Cl here, which is more electronegativity chlorine. So that bonded electron move towards chlorine direction. We have to put the cross arrow. So dipole moment is something. It is there. It is not equal to zero. For example, you take any A2 molecules. A2 means like a homo bimoleculars H2, Cl2, then Br2, I2, whatever that. Here that hydrogen and hydrogen both are same electronegativity. Here dipole moment is always that is zero. Any bimolecular always zero. So now I will discuss one more example of BF3 and NH3. So generally they are asking a question, this type of the question, first you have to write down the structure, boron with the fluorine, then fluorine. Here nitrogen, here hydrogen, then hydrogen. Here one lone pair is there, we wrote lone pair here. Here there is no lone pairs. So here, which is more electronegativity? Fluorine. Vector factor always you have to write down more electronegative direction. The arrow have to show that more electron. This is whatever the arrow cancel this arrow means it should be the top one is like this and the bottom both are two is like this. So both are cancelled. So mu equal to zero in this case. Whereas in this case, here, here the bonded electron move towards that is a lone pair direction. Here, this is a here nitrogen is a more electronegativity. Here also same thing, nitrogen more electronegativity. Here also nitrogen more electronegativity. It should be maybe something. So it is not equal to zero. So generally, if it is a mu equal to zero, generally we are calling as a non-polar solvents. Sorry, non-polar compounds. Here, this is a polar. Polar means that it should be having something, a dipole moment. This is a mu not equal to zero here. Here, mu equal to zero because both the vector factor are cancelled with opposite direction. Here, but whereas in this case, all are same direction. This is not cancelled that vector factor. So that mu equal to mu not equal to zero. Mu maybe mu equal to something. It is not equal to zero. This is it. For example, then another one is I will discuss another one. Whatever that molecule here, H2O is there, H2O. Then another one is H2S is there. Here hydrogen with sulfur. Here hydrogen with sulfur. Here hydrogen with oxygen. So here sulfur is there. Here for the first case hydrogen is there. So in this case, which is more electronegativity? So oxygen. Here, which is more electronegativity? Oxygen. Whereas in this case, here similarly lone pairs are there now. So lone pairs also it is there. So in this case also same thing, lone pairs are there. Now both are almost the same, but which is a more? Always a dipole moment is directly proportional to electronegativity. Here, which is more electronegativity? Oxygen. So that dipole moment always mu is a great. First one is a greater than second one. First one means that is water. Then second one is H2S. Okay. Now I will give that applications of dipole moment. Always dipole moment is directly proportional to electronegativity or electronegativity difference. Again, another one is the first condition. Then second one is mu is always directly proportional to lone pairs. If it is lone pairs increases, dipole moment also increases. Then Third one is mu is inversely proportional to theta. So here theta value increases, dipole moment decreases. I will tell you what is a theta then now. Any linear molecules, then fifth one, linear molecules, that is always linear molecules. Molecules always mu equal to 0. Example, I will tell you what are the term mu equal to 0. Here linear molecules are like, this is a CO2. This is a CO2 here. This is also one of the linear molecules. The bonded will come more towards that carbon to oxygen because oxygen is more electronegative. Here mu equal to 0 because both are opposite direction. Okay, you take any symmetrical molecules also, that is a like BF3, BF3. This one also, that is a symmetrical. Any symmetrical or linear molecules, symmetrical, always mu equal to 0. This is already we are explaining. Now we discuss about that theta value. For example, they will give that 1,2 dichlorobenzene. Then another one is a 1,3 dichlorobenzene means metadichlorobenzene. Another one is a para. Then generally they're asking question which is a more dipole moment. So I will tell you a simple shortcut. Then here this is a bond angle. This is a like this. This is a both the chlorines are like this. We have chlorine. Then I call this is a 60 degrees. Whereas in this case, this one, both the chlorines are here 120. Here both the chlorines are 180. Chlorine. So here, which is a so here what we wrote, the final conclusion, theta value increases, dipole moment decreases. So that always ortho is a more dipole moment, ortho is a more dipole moment than meta, then para. If they will give the cis and trans, always cis is a more dipole moment than trans because of trans is symmetrical. Consider symmetrical. So this is one. Another one is if they will give the question like CH3, then CH3 here H, then H. Similarly here CH3, then CH3 here H, then H. So here dipole moment always not equal to 0. Here equal to 0 because it is a symmetrical. It is a symmetrical nature. So generally, if you are cutting like this, we get two equal halves. If you are cutting like this, two equal halves. But we are not getting two equal halves because one is in plane, another one is out plane. So generally here, which is more electronegativity, carbon. So bonded electrons. Here, which is more electronegativity, carbon. So both are opposite direction. To cancel that, then it is unequal to 0. Whereas this one, this is opposite direction. Okay, so that me equal to something is there. This is a for that dipole moment. Then one more is a formula charge. Formula charge. Thus, I will discuss that is a simple trick to find out the formula charge of any molecule. Any molecule. So here, just simply that formula charge equal to number of valency electrons, number of valency electrons minus number of dots means lone pairs minus number of lines means bonds, number of lines means that is also bonds. For example, I will discuss here like this is one of the famous like ozone molecule we have to discuss. Plus here only one lone pair. Here negative charge means we consider this is also one lone pair. Shall I write like three lone pairs? Here one lone pair, one lone pair, here one lone pair, here two lone pairs are there. So here negative means generally we wrote like this: O double bond O plus then O minus, here lone pair, here lone pairs. So this lone pair also we consider as a one like that negative charge also we consider as a one lone pair. Here we are giving the numbering 1, so 2, then 3. So here we find out the formula charge formula charge for first one. Formula charge for first one. So here this is a first one. So here first oxygen one, here equal to, here what is the group number? Sixth group element. So valence electrons are six, minus here how many lone pairs are there? Here only one lone pair is there, so minus two. So here number of lines, one, two, three. So here three. So this is a six minus five. It is one. It should be plus one. That's what we wrote plus one. So whereas in this case, the second one, formula charge oxygen 2 equal to here same group number, here number of lone pairs how many? So here only two are there, here four. Four minus here number of bonds, here two, it is zero. That's what here there is no charge. Whereas here O3 molecule, so O3, so third one, formula charge for O3, here formula charge for O2. So this one, second one, third oxygen, here 6 minus, here how many? 1, 2, 3. So here also how many? So 6, again here how many bonds? 1 minus 1. So it is a minus 1. That's what we wrote, it is a minus 1. Minus 1 and plus 1. This is the formula charge of any molecule.